fucking Kepler died recently. You see its last image, there were 2 pixels that were dead. Because it ran out of juice.
And the rover died too, right?
Yeah. 13 years after the mission ended or something like that. You know, I've always been actually extremely impressed by the robots that we've sent to Mars that all last like a minimum of a decade longer than the operational requirements, and they send us just, I guess it's not like they send us new information, because they can only really find certain types of information, because they're really highly skilled at finding specific types of information. And lo and behold, Mars's surface is fairly homogenized after millennia of dust storms. But the images are still good, and the climate data is still really important, because it's time to understand and appreciate how Mars arrived at the state that it's in now, and it advances our own climate models.
Well, they know they know it has seasons now, which is where
that's important. Yeah, that's really important.
Because part of that is when the ice forms during the winter, so they not only know it has water, but that the the hydrodynamic flow in the atmosphere is enough to cause ice sheets on the mountains or something.
Yeah, because what was it? Before we had like satellite data of ice accretion at the poles, but we weren't really sure why, and we could tell that there was it had to have been some kind of sublimation, because we didn't see it melting.
Right.
It had to go somewhere, but it kept forming and then going away. And now we know.
Yeah.
It's like, seasons, duh. Of course it has fucking seasons. It rotates and it orbits the sun.
Yeah. I mean, at the same time, then, I think a lot of assumptions about other planets will probably have to then change based on how we have an understanding of Mars now and what can exist there. Not even in the Goldilocks zone.
Yeah.
Because that's a pretty big deal, for there to be water that is seasonal, but not, I guess the surface of that planet is probably going to be really, like the dark side of the moon, maybe.
Yeah.
I don't know if it's colder than, I would imagine it's probably colder than that, but
I think like any, well, it has long days, so yeah, long nights, so it probably gets pretty cold at night.
Yeah.
And it probably gets really hot during the day, because it's all about exposure. The length of exposure, not like really proximity, because photons are photons. They don't care how far they travel. I mean, eventually they disperse, because they're not all going the same absolute direction, because it's not a laser. But, and that's one thing that's always, I thought was always interesting about the concept of using solar sails, or light sail, is that we could just send them along a path with a really bright ass laser. I always thought that was really interesting. Like, oh yeah, that's ready to go? Hold on. Jimmy, power up the laser. But then, why not just put the laser behind the sail on the ship? It's space, right?
I think the issue is that
the power supply.
Right. Yeah. Which is where it's not about, technically that theoretically could work.
Even though that's
I guess you'd have to have the laser tethered to the ship and not direct. You'd have to have some weird physics working with that, so it's not attached to your ship and offsetting the inertia.
I think it has to be the mass of the laser itself has to be less than the quality of inertia created from the transfer to the solar sail.
Right.
So
Otherwise, they would. If it's not, then they would just offset each other.
yeah, it would just heat the thing up and eventually burst into flames.
Yeah. Which is where, I mean, if you had the laser on the ship, you could. I don't even know if you could push off of anything necessarily if that's powerful enough.
Yeah.
Um,
Well, maybe it's just a matter of having sails comprised of materials that can catch something more than photons.
right. Yeah. You should be able to switch it to like neutrons
Yeah.
or dark matter or tachyons or
Yeah, there might
like,
be a tachyon sail. That'd be crazy. That's the time sail.
Yeah.
You can get to your destination faster than you can possibly imagine. That's like warp sailing.
That's what I mean. Yeah,
Like,
I think that's the type of thing that if we can figure out if obviously if there is a particle that moves faster than light in reality, I I mean the rules of physics are restricted in this plane, but that doesn't mean there's not a universe that overlaps with ours in which that doesn't.
yeah, because a lot of these a lot of the multiverse theories kind of rely on universes that are so far away from each other there's no chance of interaction.
Mm-hmm.
Like you can't escape the first universe, let alone get to the next one, because it's like 20 universes in distance away or size of way, right? Something like that, something dumb. But then there are an infinite number of universes all sitting in some weird cube grid thing, right?
I mean that's one possibility, but they could all overlap.
Yeah, they could be
in the same physical space,
but out of phase with each other or something like that.
Exactly, and just vibrating at different frequencies. That's another.
So we've got
theory.
An infinite group of universes that are all aligned, and then we've got the grid version of that.
Mm-hmm.
So there's like an infinite number.
Those could be coexisting at the same time.
Overlapped, out of phase realities.
Why can't it be both of those?
No, that's what I'm trying to. I'm trying to imagine a version of all of those things.
Yeah.
And then they're also all linked with a bunch of strings.
And they're all, like liquid in their motion between things, but they can't perceive that liquidity.
Some just appear and then randomly disappear and then reappear.
I mean, and that's part of why, in the sense of if the movement of matter in space-time seems to mimic the movement of a stone hitting a body of water, that principle of how action and reaction ripple seems to be kind of a universal reaction, in the sense of, at the core, if you affect a molecule, it's going to ripple out in the same way that we call it the butterfly effect. Affecting one molecule ripples out where it eventually affects all molecules.
Yeah.
And
it's interesting.
It's that chain reaction. It just takes time.
I've always enjoyed watching light shimmer in little pools of water and then dropping pebbles in them. And you watch the light shimmer. It moves and it like dances. And depending on the size of the body of water, even sometimes it can be as small as a pothole, and it'll have its own like unique expansion of the ripple. And it's cool to see it, because I imagine that's what sound is like too. Because when you get close enough and you drop it in the pebble, you can hear that kind of a whoop noise as it goes in. Well, and so you can see the sound wave.
Yeah, the cymoglyphs are real, in the sense of they know that the dolphins have cymoglyphic speech patterns now. So it's not just tonal, and it's not just frequency and number of clicks or tones, but there is a shape to the sound as well.
Yeah.
Which is fucking amazing. But nobody even thought to have analyzed this shape of sound, for a long time. I mean, I think it's like relatively, mid-1900s or something
Yeah.
they started
Well, I don't
researching
think
the concept.
that also kind of coincides with the real emergence of accurate microphones and testing equipment,
Mm-hmm.
and the dynamo is fully realized at this point in the.
Yeah.
So I think that it's interesting that like there are some things like computer science, the theories that computer science are based on existed long before computers existed, and there are theories of like Fourier synthesis even I think existed on paper before synthesizers existed.
Mm-hmm.
And so there are these schools of physics and science that predate their physical ability to produce the hardware that they're dreaming of.
Mm-hmm.
And I think that's really cool. I mean, I know that
I think in most cases, like anything complex is that way. I mean, you look at Tesla's writings, he wrote everything out before he built it. And it's so dense that I dare anybody to actually try to make it through like a fucking chapter in a day.
I feel like he probably wrote in several languages at the same time. I feel like he's like one of those dudes.
Yeah, I think it took me maybe probably 3 days to get through like a 15-page chapter of him describing.
Yeah, but like
alternating.
I think it's the difference between Tesla writing out like alternating current theory and from going from that to actually building it, and the difference between like the theoretical foundations of computer science and the first computer, like that amount of time is very significantly different. Like, because he was obviously much more sophisticated in terms of being able to go from idea to execution. Like, computers took a while to get from where they were to where they are.
The theory was like, oh man, they were so far ahead of themselves. Like, the theory of the internet was like very solid in the 60s.
That's what I mean. Well, it was. We had the whatchamacallit, the telegraph.
Right.
The South Pacific Railroad and Telegraph, or Continental Railroad and Telegraph thing. Like, that was that was long distance communication. I mean, that was the that was an early form of it, but even then they were, like you said, I mean, they were envisioning that future like way in advance.
And what's really interesting about, and this is one of the things that I get into in terms of trying to go from idea to reality. If you have something that's super complex and you try to go from idea to reality without a bunch of planning and writing, you're not going to get very close to your idea. Whereas somebody like Tesla, because his writings were so dense and in depth, he was probably almost spot on with what was in his head engineering wise, because he iterated so much on paper.
It's like Beethoven, who who like just knew that it sounded like that way, and we listened to it. It's like, man, that guy's a genius. He was deaf, really? Yeah.
I mean, that's, again, that's a whole different thing where this comes to the people who can explain it and write it down, but also are oftentimes the same ones that are saying they're given these ideas, are why it becomes difficult for people who can't reproduce those things to believe them about how they get the ideas, and then try to say that that's not accurate. And this is, to me, one of the
you know what I just heard you just say is reading is hard for some people.
Well, I mean,
and I'm not saying that like anyone can just go and read Tesla. Like, I have some scientist friends who I've looked at their notes and it's like, what the is that Klingon? They're like, I'm glad you noticed, and it's like, oh man, you're fucking writing your notes in fucking Klingon. What the fuck? That's beautiful though, actually. You know, like
Yeah.
that's some like ultimate nerd level shit. Like I bow to your mastery.